timely and relevant topic regarding assessing the impact of questionnaire changes when facing budget or time constraints. The approach used here involves an online web survey or an appropriately socially distant survey mode, which, as you can imagine, during this lengthy pandemic period, when in-person data collection and opportunities for experimental treatments that might otherwise be embedded in personal visit fieldwork are limited by COVID-19 related protocol restrictions, it's even more important to consider alternative options for question testing. So our speaker today is Dr. Stephanie Ekman. Dr. Ekman is a survey research fellow at RTI International. She conducts research into data quality and the social construction of data. Her main interest areas are using passive data to supplement or replace survey data, the shortcuts respondents take to reduce the length of surveys, and innovative sample designs. 3 quick housekeeping items that I'll mention. During the presentation, feel free to use the chat function to ask questions. We'll go through the questions in the chat at the end of the presentation, as well as take any others that might come up. Also, just a reminder to mute your microphones. And finally, I just want to make sure that everyone knows that the session will be recorded and then later posted to the WSS YouTube channel. So with that, I'll turn the floor over to Stephanie.
Thank you, Adam and Jeff and WSS for organizing this. I was told there were going to be about 10 people attending, so I'm surprised to see quite this many, but excited because I think this work is potentially valuable to the government, the Federal Statistical Society, the governmental statistical community. So I'm happy to show you what I've got and hear your questions and concerns with it. This work I'm going to be presenting is currently under review. So I have a draft paper out there that I can share if you want more details. I'm not going to go through a lot of the statistical details here. They're in the paper. They don't make for great presentation material. Let me share my screen here and go back up to the beginning of the talk as well. Here we are. So I have changed the name of this talk several times. If you came to this via different sources, you may have seen a slightly different title. I would love to tell you that that was all like a carefully, randomly controlled experiment, but it was not. I'm just sort of playing with what do I want to call this. So the version on this slide is assessing questionnaire changes when experiments are not possible. And I'm really motivated in doing this work by the challenges faced by the federal statistical system, shrinking budgets, compressed time schedules, a lot of different stakeholders who want certain changes in the questionnaire, but also want things maybe not to change. Right, and so a lot of pressures, like I'm particularly talking to Adam about the redesigning the consumer expenditure survey, which they're doing now and have been doing for a few years. There's a lot of different pressures that he's under to keep the questionnaire the same / change it, from different people. And so I wanted to think about how do we study hypothetical changes to a questionnaire? And that's what motivated this research, which was part of my ASA, NSF, BLS fellowship. So I spent 2.5 years working closely with the BLS staff members and their data. That said, I think this approach could be applied to other surveys, and I'd love to hear from you guys about what you think, if this could work for your surveys, if you're interested in the ideas I'm presenting. And I think it could be used not only to look at sort of hypothetical changes, what if we were to do the consumer expenditure survey differently, but also retrospectively, right? Like we did change the questionnaire and we want to know, what if we hadn't? What if we had asked the previous version of the questionnaire? And in that way, you can really help control and measure the changes in trends, I think. I haven't done that here, but it's just an idea that I'm playing with as another application of the process that I'm going to show you today. So here's the link. Thank you to Rafael Nishimura, who I know is in attendance, who showed me that I can point on the slide here like this. So this is the link to the working paper if you want to see that. So of course, I work at RTI and I am not a federal statistical service member, but I do have a lot of you as clients, right? I work on a lot of these big government surveys. And of course, they're measuring trends. For instance, RTI is very well known for the National Survey on Drug Use and Health that we do for SAMHSA. And so there we're interested in trends, different drugs over time and by age groups and so on. And we don't want to confound changes in trend with changes in the questionnaires. The real big concern that SAMHSA and other clients, many of you I'm sure have. So I wanted this method to look at how hypothetical changes in the questionnaire. Of course, the best approach there would be to do an experiment. Now, not the kind of experiment that this guy is doing with this crazy purple liquid in his test tube, but an experiment where you split the sample in half, and you give one version of the questionnaire to half the sample and another version to another, and you compare the responses there. That's obviously the best sort of statistical approach to measuring the effect of a questionnaire change. But I realize, and I have come to realize even more so in recent years, working at the BLS, that's just not always possible. It's not feasible within the budget or the schedule or many other constraints that you all face. So, so that's what motivated this approach. So I really want to look at what if we had some ideas about how to improve the questionnaire, and the overriding example I'm going to use during this presentation is the Consumer Expenditure Survey. So if we have an idea of how we think we could potentially improve the Consumer Expenditure Survey, and we want to estimate what would be the effect of that questionnaire change, but we don't have the ability to do an experiment for some reason. So my approach here, I'm going to use a web survey. In my case, it's a non-probability web survey, but it wouldn't have to be, and multiple imputation to impute those hypothetical responses. How would the respondents have answered questions in this hypothetical unasked format? And the particular type of questions that I'm looking at, those of you who have seen the many papers I've published on this topic won't be surprised, is with filter questions. So the Consumer Expenditure Survey asks a lot of filter questions. And what I mean by filter questions is these kind of yes/no questions that trigger follow-ups. So here's the interviewer in green who goes to the respondent's house and says, has anyone in this household had any expenses for oil change, lubrication, or oil filter? And the respondent, shown in purple, says yes. And that yes answer then triggers a bunch of additional questions. Has this expense included labor? In what month was this expense? What was the total cost? And the respondent answers those questions. And then there's another filter question. Has anyone in this household had any expenses for tire purchases or mounting? And the respondent says yes. Because I'm trying to show here that she's maybe catching on, like, wait a minute, if I say yes, am I going to get those follow-ups again? And so maybe not right away, but after several of these questions or several sections of these questions, the respondent may begin to do what I call motivated misreporting. She may start to say no, even when the answer is yes, in order to make the survey shorter. And maybe she's not outright lying. Maybe she's like, was it in the last 3 months? Maybe that was 4 months ago. I'm going to say no, because I think that was probably 4 months ago, right? And so this is the current version, or this is a stylized depiction of the current version of the Consumer Expenditure Survey. It asks a lot of these filter questions in this format, which I call the interleaved format. It asks actually about 60 or sometimes 90 minutes of these questions, depending on how many yes answers the respondent gives, right? And so it works like this. There's a purchase question, yes, no, the follow-up, 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 another purchase question, follow-up, 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 another purchase question, follow-up, follow-up, follow-up. And I and many others have wondered and worried if maybe that format reveals to the respondent, if you say no, this whole thing will go faster, will be done earlier, right? And so respondents can learn that the interview lasts longer if they answer yes, and they then start to answer no to some of those filter questions to avoid the follow-ups. That's motivated misreporting. We've shown my work and work with others, and work by others has shown that this phenomenon happens. We've done it across countries, across modes, across topics. It doesn't always happen, but it is a pretty robust finding. So I worry a lot that this would happen in the Consumer Expenditure Survey because it's so lengthy and has so many of these questions. Now, I'm sorry, I do not remember what I was going to say there. I was going to make another point, but I don't remember what it was. Okay, so there is another way we could ask these questions, and this is what I call the grouped format. So these are the exact same questions that we saw on the previous slide. Actually, there's one additional one here, but they're just asked in a slightly different order. So the interviewer says, has this household had any expenses for oil change, lubrication, or oil filter? The respondent says yes. Has this household had any expenses for tire purchases or mounting? The respondent says yes. And then it goes on and asks additional purchase, yes, no, filter questions, right? So the way this format worked, the group format, the interviewer first asks all these yes, no purchase questions, and then asks all the triggered follow-ups. Okay, now a while ago, you said that you had, or someone in this household had expenses for oil change, lubrication, or filter. How much was that expense? In what month was that expense, right? So you could ask purchase questions, and then all of the triggered follow-ups. And so a lot of the research that I and others have done is to shows that this format will get you more yes answers to the purchase questions. Now, there are some trade-offs. It can lead to lower quality in the follow-up. I'm not going to get into the exact motivated misreporting phenomenon here. I have a lot of papers on that. We can discuss that in the follow-up. But I want to say that the hypothetical version of the consumer expenditure survey that I'm interested in estimating here is how would the purchase reports that the CE collects be different if we had asked them in the group format? Excuse me. Just need to write my notes. So I'm going to use a web survey to administer both forms of this questionnaire, the interleaved, the current version of the consumer expenditure survey, and the grouped format, this new version that I'm proposing, and multiply impute the responses. How would the real consumer expenditure survey respondents answer if they had been asked in the grouped format? I'm drawing on a lot of previous work here, using multiple imputation in similar ways to impute across surveys. The first paper that I found about this, one of the reviewers pointed me to this paper, is by Rendell et al. This is a slightly different application, but they use this term cross-survey imputation that I really like. So in survey 2 here, they've got a background variable called x1, and they've got a background variable called x2, and they've got the main variable of interest, y. They want to run a regression, right, where they use x1 and x2 to predict y, to understand why. And then they've got this other, better, bigger survey, survey 1. The problem with survey 1 is that it doesn't have that x2 variable. It's missing, right? That's what this empty circle here is meant to convey. So they can't run this model on survey 1. So they use survey 2 to impute what would the responses be to x2 on survey 1. So they use all this data here from survey 2 and the non-missing data in survey 1 to impute this x2 on survey 1. They use this technique. They show that it works really well in their application. And they say that one of the reasons it works well is because the variables are jointly observed. There is a survey, survey 2, where we've got all 3 variables included, x1, x2, and y. And that makes this imputation possible, is what Rendell et al. Argue. There are a bunch of other papers that relax that jointly observed assumption. So these are papers that impute across modes. So we've got a web survey that has some background variables, x, and responses to the main variable of interest collected on the web. And then we've got a phone survey that asks the same background variables and has some responses collected via phone, right? But there's this jointly observed assumption is violated because there's no data set and no person who answered both on web and on phone, right? Nevertheless, these articles use multiple imputation to impute how would these phone respondents have answered if they had been asked in the web mode. And they argue, and that's not all of them are web and phone, but several of them are. The idea here being that because the web doesn't have interviewers, you're getting better responses to the sensitive questions. So that's why they're imputing into web. Alternatively, you could impute into the phone if you felt that that was the better approach. So here we've relaxed that jointly observed assumption in these papers. And then there's this Kim et al. Paper, which I really like, which uses a similar approach to impute from a non-probability survey to a probability survey. So in the non-prob survey, we've got the background variables we're interested in and the Y outcome that we're interested in. And then we have a higher quality probability survey, but it doesn't have that Y variable for some reason. They didn't ask that question that we're most interested in, the dependent variable in our analyses. but they use this non-probability survey to impute the Y variable up here in the probability survey. And again, here we do have the jointly observed observations, right? So we do have a survey where we've got both variables or all the variables of interest that are measured, and we're imputing up here where they're not jointly observed. So the approach I'm going to use is sort of a mishmash of all of these, and here's how it looks. I've got Adam's consumer expenditure survey data, right? I've got some background variables that are measured there: income, household size, housing unit characteristics, and so on. And this consumer expenditure survey asks questions in the interleaved format only. Then I conducted a web survey. I used a non-probability web survey. One could also use a probability, where I asked the same background variables, or as many of them as I could fit. And then I asked, of 50% of the respondents, I asked those purchase questions in the interleave format. And for 50% of the respondents, I asked the purchase questions in the grouped format. And I'm going to use all of this data, all these small dots here, to impute what's missing, which is how would the consumer expenditure respondents have answered had they been asked in the grouped format. And I use this icon here. It sort of looks like a flower that has a bunch of different leaves on it. I thought it would suggested multiple imputation. So I'm going to not just do one imputation of the missing data there, but multiple imputations to make the imputation robust to a lot of different things, hopefully. So there's a lot of different ways that I could do this imputation, right? I could impute sort of from the bottom to the top, from the web survey to the consumer expenditure survey, and that's indicated here by this blue circle. This is what I would call like the survey effect. So the web survey is different. It's a different mode. The people who do the web survey necessarily have web access, right? They're sort of web savvy. So we would expect the answers to differ between the real consumer expenditure survey and the web survey for that reason. It's just a survey effect, a mode effect, respondent effect, all sorts of things going on there, right? So I could just say, okay, in the interleave format, the difference in reporting is X%, and then apply that X over here, right? I could just make an adjustment factor and adjust from this dot up here. That's one way, pretty naive way, that I could impute the data. I could also condition it on these background variables to get a little more sophisticated. I could also do it more horizontally. So I could look at just the questionnaire effect, the format effect, perhaps would be a better term here. So in the web survey, I can say the difference in the purchase probability from the interleave to the group format is Y percentage points. And I could take that Y adjustment factor and apply it up here, right? I could increase or decrease this dot here and impute this grouped reporting here. Again, I could condition on those background variables. So those are sort of two different ways that I could impute the missing responses there. In fact, I'm going to do a bunch of different ways and see how they affect the responses that I get. Again, the variables are not jointly observed in my application. I don't have anybody who answered the survey in both the interleaved and the grouped format. And that was on purpose. I mean, could you imagine doing a 60 to 90 minute survey about your household purchases twice, right? That would be rough. So I didn't ask anybody to do that. The web survey, of course, was not 60 to 90 minutes long. It was about 20 minutes. But what I do have going for me here is that the missingness is really by design. So a lot of times when we use multiple imputation to impute item missing data, it's because respondents made a deliberate decision not to answer a question. I don't want to tell you what my income is. I don't want to discuss my drug use, right? So the data is not missing by design. Here, the missingness is by design. The people in the consumer expenditure survey just didn't get the questions in the group format. It's not that they didn't choose to answer them in the group format, right? They never saw them. And so that is helping my models make some sensible predictions here. Here's, again, just showing you how the procedure works. I'm going to multiply impute the responses here indicated by this floral looking thing. And I'm doing this not at the person level, but at the item level. I've got 16 items that I copied from the consumer expenditure survey into the web survey. I didn't do the whole consumer expenditure survey. It's just too long and the questions are complex. So I just picked out 3 sections and 16 items. So the imputation is done at the item person level. You know, did Stephanie purchase pants? Did Stephanie purchase shoes? And so the response is always just a dummy yes or no. I'm going to use 12 different models to impute that missing variable. I tried to motivate the survey effect and the format effect. The actual models I use are a bit more complex than that, but I used 12 different models. And I took 20 imputations from each model. So from each model, I got not just one yes or no, but 20 different yes, no answers for each person and each item. And I'm going to use all these responses to impute. I used all these responses to impute the yes, no answers, and then use all of those answers to study the difference between the interleaved and the grouped format. The predictors in the models are all the background variables that I have that are both in the consumer expenditure survey and also in the web survey, as well as which version did you get, interleaved versus grouped, which survey were you in, CE versus web survey, and so on. So here are the 23 background variables that were asked in the consumer expenditure survey and that I also asked in my web survey. These are all categorical except for a number of household members, which is continuous. So of these 23 variables, 17 of them showed significant differences between the two surveys. The consumer expenditure survey has different people in it than the web survey. The web survey respondents tended to be a little bit better off than the consumer expenditure survey respondents on average. So I wasn't surprised to see significant differences. Significant differences here too don't invalidate my approach because I can control for all these variables. I'm much more concerned about differences in variables that aren't on this list, right? That I haven't measured in the web survey, that aren't measured in the consumer expenditure survey, because I can't control for those. And that's just an assumption of the method that I'm using. There's nothing I can do about that. It's a common assumption in causal inference as well. The whole approach rests on the idea that after controlling for these variables, there are no remaining important differences between the two groups of respondents. One thing that I have going for me is I have representation in each category. So it's not the case that, say, everyone in the web survey owns their own home. And so there's no representation of non-homeowners in the web survey, or that no one in the web survey has self-employment income, right? I don't have equal proportions across the two surveys in the different categories, but I've got all the categories represented in each of the two surveys, which is beneficial. Another way to compare the respondents to the two surveys is to look at their purchase habits. If the purchase habits were very different on the 16 items that I'm interested in, that would also concern me. They don't look too bad to me. Some of the times the purchases for the web and the consumer expenditure survey are very close. And I realize now I cut off the legend and I don't know which one is consumer expenditure right now and which one is web, but that's fine. I can look that up if anyone is worried about it. But the purchase rates, the probability of purchasing each of these things in the two surveys is generally pretty similar. Sometimes we see some differences, like here for coat, here for life insurance and homeowners insurance. Across the 16 different purchases, 13 of them had significant differences. But the purchase rates were very correlated, 93% correlated. So I see this again as support for using this approach. So I said I built 12 different imputation models. Let's look at briefly, there's more details in the paper, at how that worked. Here's model 1. The dependent variable in all the models is, did you purchase a given item? Life insurance, a coat, electricity, fuel oil, things like this, right? And so the independent variables in model 1 are the grouped versus, whether you're in the grouped versus the interleaved format, whether you're in the consumer expenditure survey versus the web survey, which item it is. So is it a coat or is it homeowners insurance or what? The section order, I didn't get into that. Let's skip that one. And then the household, housing unit, and respondent characteristics that we saw on the previous slide, including income. And the way to read this is that this A here indicates that this variable is interacted with these B variables down here. So I've interacted the grouped versus interleaved indicator with all of the respondent characteristics. I've also included these controls for the survey, the item, and the order, but I didn't interact them with anything. So the X here means that they're in the model, but they're not interacted. Oh, that's what that says. Yep. Model 2 looks like this. All the same variables are included, but I've changed which interaction I've included. So now the interaction is between the survey and the characteristics of the housing unit, household, and respondent. And the other models differ in similar ways. So all the models contain all of the variables. I'm just changing what the interaction is. Our model 3 doesn't have any interactions. Model 4, the interaction is between the format and the item. I tried to include everything I could think of, everything that seemed reasonable. The difference between models 1 through 6 and models 7 through 12, they are exactly the same, except models 7 through 12 do not include income, because income is difficult to measure in the web survey. The Consumer Expenditure Survey has a lot of questions about income, goes through many different sources. In the web survey, I worried that people would not answer that many questions, so I reduced the number. And the reviewers felt that it wasn't really possible to claim that those income measures were comparable. So I instead of having just 6 models with the different interactions, I now have 12 because I've dropped income from models 7 through 12. The best 2 models in terms of the AIC and the BIC are model 5 and model 11. One of them was best according to the AIC and the other one was best according to the BIC. But they're very similar. Models 5 and 11 are a pair in that, they have exactly the same interactions. It's just that 11 drops household income. So model 1 and model 7 are the same, 2 and 8 are the same, except for that removal of income. And so 5 and 11 are the same as well. Here's a scatter plot showing you how the predictions differ from the models. So the horizontal axis and all these little graphs, and I know you can't really read all the graphs, it doesn't matter too much, it's just a takeaway that how the models perform against each other. The horizontal axis on each of these is 0% to 100%. So down here we see this is 0% and this is 100%, of course. On the main diagonal, we see the density plot, so how the distribution of predictions from a given model look. So in this one right here, this is model 5, and we see the distribution of responses. We get a lot of no's, fewer around 50%, and then not too many around 100% probability of purchasing these different items. And then in these off-diagonal plots, we see 2 models compared against each other. So for example, here we see that model 4 and model 3, this cloud of scatter plotted points is very narrow, suggesting that model 3 and model 4 are performing very similarly. They're giving very similar predictions. Whereas here, model 2 and model 5 are giving very different predictions. That cloud of scatter plotted points is much wider and thicker. So what the takeaway here is that the models are, they're capturing slightly different things. Some of the pairs of models are very similar, but some of the models are different. And so using these 12 models is capturing different aspects of this purchase decision and making the set of predictions more diverse. Okay, so now we're going to get to the punchline. Again, here's the setup. And what I'm really interested in, once I get this data imputed using all those models, 20 predictions from each of those 12 models, I'm going to look at the difference in the percent yes achieved from the interleave format, the current version of the Consumer Expenditure Survey, and the percent yes achieved from this hypothetical imputed grouped format. So here's how the predictions look from model 1. So that difference that I showed, the percent interleaved, the percent yes in the interleaved minus the percent yes in the grouped is very close to 0. The confidence interval spans 0. Model 1 suggests there's not a lot of difference between these 2 approaches. But if we look at the other models, 2 through 12, most of the models say that there are differences between those 2 formats. All of these points, these 10 points lie below the line. Their confidence intervals lie below the line, meaning that the interleave format collects fewer yes responses than the grouped format. And that's what we would expect. That's what all the previous literature, or most of the previous literature, has shown, right? In the interleave format, respondents catch on. They start to motivatedly misreport to those filter questions and say, no, I didn't have any tire money. No, I don't have any homeowners insurance. No. right? We should get more no's or fewer yeses in the interleave format than the group format. So 2 of my models, 1 and 7, again, those are a pair, those are very similar models, are saying that there's no difference in the 2 formats, but 10 of my 12 models are saying that there is a difference and that the interleave format leads to underreporting of purchases in the consumer expenditure survey. This is called a specification curve, right? Where I'm looking at the answers that I get from my model across different specifications of that model. So rather than engaging in a detailed argument about exactly which interactions are the most important ones to include in the model, I included all of them in different models and then showed that the answers are pretty much in line. You can see there are some differences here. The models disagree about how much motivated misreporting is going on, but 10 of my 12 models say that it is happening. If I break this up into the different sections, so I chose questions from the utilities section, homeowners insurance, rental insurance, car insurance, and so on. Oh, excuse me, this is the insurance section. Utilities, fuel, oil, electricity, gas, things like that, and the clothing section. Did you buy a coat? Did you buy shoes? So if I break the results up across the sections, you can see in the utilities section, the models really disagree about what's going on. In the insurance section, it looks like there's some motivated misreporting. 10 of the 12 models say that, but all 12 models agree that there's motivated misreporting going on in the clothing section. And we've used these clothing questions in a lot of different surveys, and we have shown that the effect is really robust with these clothing questions. Have you purchased shoes? Have you purchased pants? And so on. So I think this is the best evidence to date of underreporting in the first wave of the consumer expenditure survey. These results are robust to the specification of the imputation model. I also I didn't put that on the slides, but I also took all of the 240 imputations and shoved them into one model and showed that the results are in line with the majority of the models on the previous slide. So I think that's a takeaway for Adam and others from the BLS. But for the rest of you in the audience, I think that this method could be used to assess hypothetical changes in other ongoing surveys. So if you have a favorite survey and you want to know, hey, what if we change the questionnaire like this? You can use this approach to study that. I think it could also be used backwards to say, oh, we did change our questionnaire, but now some of our stakeholders are asking, well, wait a minute, what would have happened if you hadn't changed the questionnaire? I want to look at the trend line without the questionnaire change. Well, you can use this method to retroactively go back and say, hey, what if we hadn't changed the questionnaire? I haven't done that, but I'd be really interested in hearing about a potential application like that. And then if you did want to implement an approach like this, how do you do it? I think it's important to ask really as many of these background questions as you can fit in the web survey. So you have to pick questions that are already in the main survey, the consumer expenditure or what have you, right? But as many background questions as you can draw from that, ask those in the web survey as well. I used a non-probability survey. I feel like it worked rather well here, but I understand that other people will be nervous about that, more conservative. And so some of you may want to use the probability survey as the web survey for insurance to make sure you're representing everybody. Thank you very much. Again, here is the paper if you wanted to read that and other information about how you can get a hold of me. Thank you. Looking forward to questions and turning this off.
Yeah, great. Thanks, Stephanie. That was really interesting. I didn't see any questions in the chat other than people asking about whether or not a recording would be made available after the session, which Jeffrey responded to. Does anyone have any other questions that they didn't put into the chat? And oh, I do see one hand up. Raphael?
Hi.
Hey, Raphael.
Hi, Stephanie. Hey, good presentation. Thank you. Just a question on if I understood like what you're trying to do here. So it sounds that like you ran the experiment like in the web survey. You have like half of the respondents to one type of question, the other half in another, and right. You're pretty much just trying to impute that like bit part that you didn't have on the probability-based survey to kind of get some sort of like external validation on like whether the results that you found on the web experiment kind of replicates like in a probability-based survey. So I was just wondering, like, if this is correct, like if you found that the results that you saw on the web survey were all confirmed on the results that you replicated, like that you got through the imputations on the probability survey. I know there was like some apparently differences like across different models, but I was just wondering in general.
Yeah.
If you found differences.
No, that's a good question. In the web survey, I mean, I did estimate the difference between the interleaved and the grouped in the web survey. We've done that in other studies, and so it wasn't the main issue of interest here. It was a much bigger effect in the web survey than in the consumer expenditure survey, and it was consistent in all of the sections. So, so that was a difference. You know, when I brought it into the consumer expenditure survey, it wasn't a simple replication of what you would get if you just did the web.
Got it. Okay, thank you.
And you know, what I would love to do here is like a validation, right? Like, well, then let's go change the actual consumer expenditure survey and see if it, you know, really does have the effect that I've imputed here. You know, nobody's given me several $1 million to do that, so that's probably not going to happen. But that would be really the final piece of evidence here.
Great. I don't see any other hands up at the moment. Stephanie, I had a question for you. Looking back at the percentage change or percentage points slide comparing the overall, the utility section, the clothing section, and the insurance section, I was curious if you had anything to add. You may have already said something about this and I missed it, but why the utility section shows that the interleaved format was outperforming the grouped format. That's one question. And the second question is why the clothing section seems to be a lot more, there seems to be a lot more variation in the models than the insurance, for example, or the utility section.
Let me share again so everybody sees this slide that we're talking about here. All right. Yeah, so you're asking the utilities section, what's going on there? Is there actually an opposite effect going on with the utilities section? I think the overwhelming evidence here is that there's not much going on. There's what, 1, 2, 3, 4 above, 2 below, and 6 on the line. So that sounds to me like overall not, you know, that there's no difference in the two formats. Insurance is a pretty consistent yet small effect, and then clothing is kind of all over the place. I mean, all negative, there is an effect there, but small and sometimes and large other times. Why the differences? Clothing, we've seen this before, clothing really performs well. Like it you know, if in terms of like showing this effect, it seems it always happens in clothing, at least in the studies that I've done. Why is that? I think it might be because respondents find the clothing section particularly boring and meaningless. It's my suspicion that they kind of see the purpose of like, why would the BLS be interested in tracking what I pay for utilities and insurance? But like, really, you want to know about my pants that I bought and my shoes? And I know, in fact, within BLS, if I may say this, there's been some people who said like, yeah, we should just drop that clothing section. We don't even, you know, we know that's not great data, or maybe that's not what they said, but like, you know, we don't know why we collect that. So
there are some people who say that.
Yeah, exactly. Nobody on this call. But that wasn't the question you asked. The question you asked was, why is it all over the place for the clothing section? And that's not something that I had given any thought to. I like that idea. I like that question. And I don't know why. It's more sort of variable across models in clothing than it is, say, for insurance. I haven't looked at that at all. Do you have any thoughts, Adam, or anyone?
Well, you know, my initial thought just about the utility section was that, at least as far as the interview survey is concerned, records and receipts are encouraged more often in that section. And
I
so,
see.
You know, if folks have records and receipts on hand, there might be less motivated misreporting because the cognitive burden just simply isn't there. They're sort of looking at the record. I don't know for the clothing section, but I will say to your point about concerns over quality in the clothing section, at least for the interview survey, that we are moving to asking global questions for clothing in the interview and directly sourcing the estimates from the diary as opposed to having the source selection between the two surveys.
Okay, I want to hear more about that. Thank you.
I did see one other question in the chat. I think Michael asked which multiple imputation method was used.
Predictive mean, what's it called? PMM? Predictive mean something.
Thanks.
I'm sure I've got the page marked in my book here, but I don't remember what the PMM option stands for. Do you know what it stands for, Michael?
Not offhand, but I'll look it up.
Yeah.
Yeah, at our office we use multiple inputs, and I was just trying to figure out which one your office was using.
No, I'm embarrassed that I don't know that. It is in the paper, but I don't know.
Raphael just chimed in the chat, predictive mean matching.
Okay.
Okay, great. Thanks, Raphael.
Okay, I don't see any other questions in the chat. I don't see any other hands raised. So I just want to go ahead and say thank you to Stephanie for a great presentation, and thank you to everyone for joining today. As always, WSS encourages you to send suggestions for ideas, topics, and presenters for events to the WSS Methodology Program Chair. And I believe the program chair's email is already or will be shortly entered into. Yes, I see Jeffrey's email in the chat. So please reach out to him with any suggestions. With that, thanks everyone, and I hope you have a great rest of the day.
Thank you, everybody. Bye-bye.